Good morning, everybody. November 26th, and we are continuing with Quadratics Part 1. Yesterday we looked at A and K for our vertex form. This morning we're going to take a look at H. So our learning goal just to identify how H affects the graph of x squared, and then continue with describing the transformations.
Just like we did yesterday,
so I have a little video here
Desmos,
I'm going to show you.
We're going to take a look at Vertex Form.
Like we did today.
So remember,
in Desmos.
Vertex Form right
and
here.
And just to remind
y equals
you,
ax minus h squared
our
plus
equation
k.
that
We took
we're
a look at
with, our
what a and
focus
k did
is
yesterday.
y
And if you remember,
equals
a controlled whether it opened up or
x
down,
minus h
and
squared
then made it stretched or compressed,
plus k.
or made it more
And
narrow
yesterday
or wide.
we looked at A and K.
Just moved
Today
it up
we're
and
going
down.
to look
now
at
we predicted, someone in the class predicted yesterday,
or this morning anyway, we're going
that
to take a look at just
H would move it
what
left
H
and right
does.
horizontally. So let's see if they were right. And then down here we also have our normal x squared. So this is the standard. So this black one right here is the standard, and the one that's moving is going to be the red one. So let's hit play and see what happens. As predicted yesterday, we can see that as H changes, it's moving my graph left and right. And in fact, if we slow it down a little bit, when H is positive, it's moving it to the right. And the greater it is, the further to the right it goes. And then when H is negative, it moves it left. And the bigger the negative number, the further left it goes. And maybe just for fun, we will play all of our variables. And then we can see everything is happening. It's moving left, it's moving right, it's moving up, it's moving down, opening down, becoming more narrow, and becoming wider.
One thing I forgot to mention at the start, hopefully Mr. Hack informed you, but there is no handout that goes with this morning's lesson. It's pretty short, so you are going to have to copy this down. So hopefully you already copied down the title and the date. Just paid attention to the Desmos presentation or little short video we just had, and then now is where you're starting to copy. So our conclusions. So we're going to come up with our conclusions kind of point form, then I'll give you the actual math language just like yesterday. Now here's where a little bit of confusion comes in, and you really have to wrap your head around this. Our equation. So this is the focus of our first quadratics unit, vertex form. And you're going to notice here it says when H appears negative. So we just saw when H was positive, it moved it to the right. When H was negative, it moved it to the left. But we have to keep mind of that this is actually always x minus. So when H is positive, like say it was positive 2, positive 3, positive 4, I put that in for H, it's x minus 4 squared. So it appears negative. If we had a negative value for H, so if we had negative 1, negative 2, negative 3, negative 4, we just saw that it moves it to the left. But since my equation is always x minus, when I put in, say, negative 3 for H, two negatives, what do two negatives make? They make a positive. So when it comes to the h value, it's kind of, when it comes to x, opposite to what you see. So when h appears negative, so that's like this one, really it means your h value was positive, which moves it to the right. So when h appears negative, my graph moved right. So whenever we have something that's x minus, it's going to move to the right. When h appears positive, so that's like this one right here, which really that meant we had a negative h value. But we know two negatives make a positive. So when h appears positive, your graph moved left. So whenever we have x plus some number, it moves it to the left. So it's kind of, when it comes to the h value, or at least moving it left and right, it's kind of opposite to how it appears, and that's just because it's always standard x minus. So if you see x minus, it goes to the right. If you see x plus, it goes to the left. So the actual math language. When h appears negative, the parabola moves right. And what you should say is shifted right, and then however many units it does. When h appears positive, the parabola moves left. Again, kind of opposite to what you think. And we would just say shifted left, however many units it is. So we're going to do a couple of examples here, and I'll just put in some random numbers. So we'll say y equals, so I'm going to put all the variables in because we've now seen all of them. So y equals to x minus 3 squared plus 4. And we want to describe all the transformations. And you might want to refer back to yesterday's note that we made as well that has the a and the k. So the first thing that we encounter is our a value. It is positive, which means opens up. And the actual value of the a is 2. And since that is bigger than 1, we say vertically stretched by 2. And that's just from yesterday. So we've done this, now we're on to this. When h appears negative, so if it's x minus, it kind of does the opposite to what you think. So, and remember that h value is truly positive because it's always x minus, but I like to think of it in terms of opposites. So I see x minus, my mind maybe goes to the left, but I remember it's the opposite of that, to the right. So we're going to say shifted right 3. And then the next thing we encounter is our k value, which is 4. And that means if it's positive, shifted up 4. Now let's come up with some other numbers. So y equals, we'll say, negative 0.5 x plus 6 squared minus 7. The first thing we encounter is that negative, which means opens down. And then we see the 0.5. And remember, if it's a decimal, that means it's not vertically stretched, it's vertically compressed. And don't write by negative 0.5. We already took care of the negative by saying opens down, so just write by 0.5. The next thing we encounter is the h value. And again, it's kind of opposite to what you think. So if it appears positive, it shifts left. So shifted left 6. And then the last thing is the k value. And that is negative. So that means shifted down 7. And that's putting it all together. So that's A, H, and K. So that's it. Pretty short lesson. You did have to copy down some of it online paper, not on a handout. And then the rest of today's note, when I get there, we will do on a handout. Here is your next achievement check. Now I have your achievement check sheets. So if you want to, you could do this on a separate piece of paper and then just transfer it to your achievement check sheet once I get there and hand yours from yesterday's back. Or you could just copy this question down, hold off, and then answer it at some point this morning. So for this one, you want to describe the transformations, and you have something that has the A, H, and K all in it. And then you are to work on section 1.3, questions 1 to 3 out of your workbook. Have a good morning. That's it. I'll see you in a little bit.